The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everybody and welcome. My name is Nathan, otherwise known as Old Man Builds. Guys, it's going to be an awesome time this week. Look, I just want to say hi to everybody in the chat. Man, you guys are awesome. We're getting through this Bedini build. I'm excited, okay? I got the coil wound the other day. It was rainy out here in California. It sucked, but I was able to get it run. Now it's 140 feet. That means from my backyard to my front yard by the street is what I had to run this. Now it's only 7 wires for the main run and then 1 trigger wire. So it's not terribly bad on that. It's the distance you have to get it at and then keep everything off the ground while you spin it. That's the pain. And then you got to keep going back and forth. You know what I mean? It's raining, stuff stuck to my shoes, whatever. You go back and forth and make sure the line was correct and how far you were to the other side of the fence and stuff like that. Other than that, man, it came out beautiful. So I want to go ahead and bring this up. We're going to share some stuff here, stuff that we're looking at for the circuit itself. So again, we're not just going with the 2-wire coil, so not just the 1 wire and the trigger wire. We're going with the 7 wire and then the 1 trigger wire. So let's take a look here, and this is the circuit we're looking at. This isn't very difficult. I've built much more difficult circuits than this. Seems pretty straightforward. You got a resistor and you got a diode there. You got a transistor in there. It has to be an NPN. They're a little bigger than normal NPNs, but that's okay. So what I did here in doing this is I ordered a heat sink that's about 11 inches by 5 inches. And that should cover this fairly easily. They don't get very hot, so we should be good. We should be looking at a temperature right around 86, 87 on it, which is just fine for an NPN. And then, like I said, I wound the coil. I'll show that in a minute. And we got all the wires there. We got batteries. I got a 30 amp hour battery for a motorcycle that I'm going to run. I also have 2 go-go scooter batteries that I got that are completely dead. We're going to see if we can't revive those. We also have a diesel battery for my truck, and we're going to see if we can revive that big boy, that deep cycle one. We may need another primary battery to get that one all the way done, but that's okay. That's what we're going to start with. So I'm looking at this and I'm going, okay, so I like this. Seems pretty straightforward. They give you all the parts in there. MJL21194-G. It's an NPN transistor. I got them on Amazon. Let's see. We had, I believe it's a 1K ohm resistor. Got that on Amazon. 1N4007 is the diode. Got that one there as well. So those are good. This is exactly what I'm going to make it look like, guys. No playing around, no games. It's going to have the same sides on it on the bottom, the same top part, everything. I got a fan not as big as that one. Got the same aluminum rim. I got the same magnets for the outside of it. And then, like I said, we'll put a heat sink in there. Mine won't pop out like that, but that's okay. It doesn't need to. We'll have the coil right under the center of it. And then there's a little piece underneath that. I think we'll need that one as well. But this thing gets cut out. I just got a mini table saw today. So I'm excited because I missed my big table saw that I had. It made these jobs so much easier. being that I used to own a cabinet company, it much easier. So I got a little mini one today. And guys, the piece I shoved through here, this thing can be done with a 4 foot long and 12-inch wide board. So that's exactly what I did. I went out and bought a piece of pine, same size, gonna make it black just like this. Had I wanted to go with something like an oak or something, I would have stained it. But again, wanted to stay true to Bedini as much as I possibly could. So we're going black on it. The only difference is at the very top here, there's a spot where a bearing goes. And they have theirs in some weird fashion up here at the top, and I'm not playing that game. I'm just going to put it through the wood the right way and sink the bearing, just like you should. And then we'll get the shaft out there to the fan. Another thing we have with the fan is I have a piece of aluminum that's fairly large. So it's close to 18 inches, and I have a center post to it. So what I'm going to do is we'll run the fan and see how it runs. And then we'll run the circular one like a flywheel, and we'll see if we can add weights to it. Excuse me. And see what that does to the system. I think if we're looking for centrifugal force out of it, and in order for it to run better, I think a flywheel might be better. So again, true to what it is, we'll put the fan out there first. We'll test it. Then we'll put the flywheel out there and see how it does. I'm absolutely stoked about this. So this is going to look just like this when I'm done. It's going to be almost an exact copy. One of the differences is going to be on the front. I'm obviously going to put the Old Man Builds logo up here and then say Bedini SG on it as well. So we'll do that. And on the back, it may say something else as well, just so they know, hey, the Old Man built it. So this is the distance right here, guys. You can take a look, and yes, I have too many barbecues back here. Right here where I'm standing is like maybe 3 feet off my fence in the back. And then all the way to the front where you see the street is, that's where that wire had to go. So I had to run it all the way over there, keep it off the ground. You can barely see it if you even can. You see those 2 bricks right there to the right of that. You barely see like a little bit of red. That's where the actual wires are going. And I made a video while I was out there doing this and took some pictures and stuff so I can write down the exact measurements and then show you guys how to pull everything tight. So when you get out there, all the wires are strand out quite a bit, in different heights. So you have to, hold them and walk along it and tighten them up. And then go over to the other side, man, and just tighten everything so it's perfect before you start winding. Then you constantly have to keep it off the ground, and everything cannot touch the ground while you're winding at all. It'll get rid of the outside coating. You don't want that. But yeah. Oh, thank you for that. Yeah. Nice decking. Yeah. Well, before it got too bad and I stopped working a lot, I put that in, and I was going to put in the island and stuff. You see all the bricks are there and everything's built on the top, and I never got to finish it. So my body ran out of steam. And then the other side over here where the barbecues are, that's a 6-inch deep slab. And I'm supposed to put a smoker in there. And I think I'm going to have to pay somebody else to do it. Because I was going to do a margarita grill on one side and the smokehouse on the other. So like a 4-foot smokehouse, and the rest was going to be margarita grill. But I never got back to it. And you see the fence is torn apart because I had to bring in a ton of concrete and then bricks, everything like that. So I had taken the fence down, never got back to put it back together. The wife's not too happy about that. But yeah, we'll get this straightened out. Just wanted to show you that, though. That was the distance. Here is the wire, the way it looks once you twist it. I don't know how well you can see that in there. It's not quite a braid, but it looks real nice twisted in there. It's a nice clean wire. We used red wire for all of the excuse me. I used 24 gauge red wire for this one on the magnet wire, and then a 26 gauge trigger. I know Bedini went to 20, but I wanted to try the higher one first. I have some 20, I don't know that I have enough. So we'll have to measure it and find out. But this is the one we ran for now. They come out beautiful looking. I don't know if you can see that, but it came out real nice. And then there it is going on the spool. You can see, man, when I put that on that main spool when we're done, I just use a 3D printing spool here. When I put it on the main spool, man, it's going to look beautiful. I mean, it is really, really nice now. So anyway, I was glad to get this done this weekend because it really sucks, man. I had, you know, the part that you put your drill, okay, and there's a little eye hook that goes on there. I didn't realize right away that it was going to snap on there because all the individual wires are put under a lot of pressure. So when you're doing this kind of stuff and you start drilling stuff, make sure your hands by that wire so you can grab it. Because what happens is you're going to have to take it off and tie it. Even though you looped it in there, those loops are not going to hold because they get too much stress. So you have to take the whole wind in there and tie it, and then it'll hold it. And you can spin everything. But yeah, you imagine that distance that we looked at earlier. You got to hold that thing up in the air and spin it and never let it touch the ground. Anytime it touches the ground, you fail because then you're scraping the ground and you get rid of the coating on the wire. And you can see here, we didn't do that at all. We kept it nice and clean. Here is the wood right here. Now, I outlined it in marker not because I need it to be done that way. You know what I mean? Because I can cut this stuff blindfolded probably. So everybody else can see how to cut the parts out of this. And the centers of them actually is going to be a piece that tapers right there. So that's not really a cutout piece. That's just where the piece goes. But I needed to illustrate for the video that I'm making that's where it goes. And like I said, I got that little mini table saw. We're talking, you know, for me, 30 minutes at the very most, and I'll have this thing completely cut out, ready to go. I'll have it over to my flush router, clean up the edges, take the sander to it, man, and I'll have this thing looking gorgeous by the end of the day. I may even build a little mini face frame in the front. I'm not sure. I know I'm going to 3D print the front and back on the middle part, excuse me, on the bottom part. But you can see here, here's the two sides on the bottom. Just like Bedini did it, this came right off of his workshop on how to get it done out of the same board. There's some spaces in between on the left and on the right, and that's just for the saw to go through. And in the center there for the saw to go through, just so people can visually take it in and what we're doing. So as you can see, there's an angle here. And anytime you have an angle, you got to cut the wood on the top in order to get it right. So we're going to do that so it makes sure it looks nice and clean and beautiful. And then there's the last piece. So you see one's the bottom, one's the top. It's going to make it look real nice. We're going to paint it black. We're going to sand it beautifully. I love working with wood, man. Like I said, I owned a cabinet shop, and I grew up as a second generation cabinet maker. This stuff right here, man, is very easy. We'll get through it pretty quick. This right here is the Bedini SG circuitry. Like I said, the other one, this is a single. The other one's multi-coil. And it's just fairly simple on how everything goes together. There's not very many connections on this. And yeah, we'll be documenting this thing the whole way. Excuse me. Wife got me sick. Anyway, so this is what we're looking at, guys. We got the aluminum wheel. Okay, already own it. Okay, got the fan, came in yesterday. We got all the wire wound already, so we're gonna wind it back on a regular spool now. We got our circuitry and stuff. We've already figured out what's going on there. I have in all the transistors, all the diodes, all of the resistors in this. And we're looking at different ways right now to get it to be seen. So I'm working on a voltage amp meter right now, and I'm trying to buy one off of somebody. And I have the voltage part, I need the amp meter. That way we can have it all so you guys can see it in real time as the thing runs. And like I said, man, I do one big build a month now. So this is the big build. So it's got to come out looking real super clean, man, just like my coils do. They got to come out just You know what I mean? I don't want to have anything that looks halfway, especially if it's going to be keeping a long time, doing lot of tests on it. So I'm excited about that, man. Um, yeah, that's our Bedini motor, man. It's not overly complicated. It's just going to take some time to put together. They're more about collecting parts. Right on, man. Yeah, we'll get this one going now. So let's talk about some of the things I'm looking for when I do this. So the whole thing about Bedini is you want to be able to pick up the back EMF, right? So those spikes. And it's opposite the Tesla coil because the Tesla coil has spikes coming out both sides all the time. It's only when you take out and put it in AC mode that you diode it to make it to have a spike on one side. So what we're looking at here is we want a back EMF spike and just catch it and throw it right into a battery. That seems fairly simple, right? It pulses, it runs around, it fills up the battery. What am I looking for? Well, when Bedini put his second coil in there, and I mean not the 7 winding plus the one trigger, not that coil. He put a whole nother one in. It acts different. And I'll tell you why it acts different. Because he says it'll go in there and it'll build capacitance like this and this and this and this, and then go. Well, what is he actually doing? He's making it AC. You'll notice that's the only one he doesn't put the full bridge rectifier on. It's because he's getting AC out of it. It's going back and forth and sloshing. As it sloshes, it forms the AC signal out of it. So out of that second coil, it's going to get AC out of it, which is really cool. You have to rectify it back to DC to put it into a battery, though. Just remember that. But you can use it as AC. So we're going to be looking for that. So expect another coil to come into the picture during testing. We're looking for the outside fan effect, so the flywheel effect. How is it going to take over here? So this is something that Tim Tron told us about the flywheel effect. It's about getting it in balance and giving and taking. So it'll be able to go faster at certain times, but then require a little power to turn it at certain times. But that's where the magic's made. That's where you get a little bit of extra. Okay. The back EMF is just simply the way the coil is wound and the way the transistor and resistor and the diodes work and what we're capturing there. So that's not a problem. I don't think we'll have any problem picking that up. Now, a lot of people ask, is it an over unity circuit? And here's how I'm going to answer that just for now, and then we'll go back and reevaluate it. Anytime that you can charge multiples to one, it becomes an over unity. Now, is it over unity by itself when it runs to charge one battery? No, I don't believe it is. Is it over unity if you charge 8 batteries from one battery? Well, yeah. I mean, if the time it takes to deplete one battery, you fill up 8 batteries, I mean, obviously we got something going on there, right? That's the question. So when we get into this, I'm going to be looking for more batteries, okay? And how many can I charge for the price of one? So I'm going to pay for it and what I pay for the one, right? And how much energy it costs me. How many do I get in return? I think that's one of the fundamental things that people miss. He goes over there and he runs this machine and he's charging 8 batteries and he's taking the power out of one. That math doesn't work out in unity or under unity. It works out in over unity, okay? So you got to get over the amount. It's a multi-system process. It's not a single one-to-one. A lot of people who do this, they put it into Chat GPT and ask, and they go, is it over unity? And it's going to come back and tell you no every time because you don't explain it to it right. You explain it to a one-to-one system, and you'll find that's what they like to answer in. And you have to break that habit of Chat GPT and say, hey, it's not a one-to-one system. It's a 1-to-8. So as soon as we have 8 charging and 1 driving, then we got it. Now, what's the problem? It charges in negative. It doesn't charge in positive. So there's ways to fix this. Now, just understand this. You could take a negative back EMF and turn it into a positive EMF if you wanted to. And you go, well, that doesn't make any sense. It doesn't make any sense. Well, sure it does. We do it with our Tesla coil all the time. We put in a basically an AC signal. We put two diodes in it and make it into a pulse DC. Okay, and it'll pulse on one side. Now you can do it on the positive wire and make a negative pulse, or you could do it on the negative wire and make a positive pulse. So there'll be a point in here where we can actually turn this around from negative energy to positive energy. I don't think people have really discussed that at all, nor do they understand it, because they didn't come from a place where you were building Tesla coils. And you have to learn how energy flows. So we can take this negative, put it into a positive, and charge the battery a different way. Now, how fast does it charge then? That's a whole different question at that point, because now we're charging with positive voltage. It charges probably a lot slower, which means our multiples go down. Will it be over unity at that point? Probably not. Will it be able to, work on a normal car or everything for normal circuits? Yes, it will. So you got to really decide what you're looking for out of this. So that's a couple things I'm curious about when I do this. You know what I mean? So I'm kind of setting some goals here along with the expectations of what I should get. I should get a nice clean pulse motor out of this. Exactly what a Bedini circuit is, okay? Nice and clean, okay? It's built with a jewel thief circuit. If you didn't understand that already, it is. It's exactly the way it is. You saturate the core and then it bursts. And when it bursts, you get the spike. That's exactly what a jewel thief circuit does. This is the same circuit here, okay? Just understand that outright. It's not some big invention that goes on here. That's what it is. But knowing that helps you out. There's another thing I want to bring into this. I want to bring in barium titanate. And there's a very specific reason for this. When you use piezo discs and you use barium titanate, now we're talking ones that are about this size. Okay, they're about $10 on Amazon. And just look it up based on the name I told you, the barium titanate. Now, it's a very specific metal for a specific reason. Barium titanate, whether it's in a piezo or a capacitor, they make both, okay? It's a fast fill, fast discharge. That's why it works so well. But what does that mean to systems here? It means that it'll pull in the negative or positive energy at a very fast rate. It'll also discharge it into other capacitors very fast. But in the piezo itself, it doubles the voltage. So if you're looking for a 600 spike on there on your negative voltage, we're going to be looking for 1200. Okay. Now, does that mean instead of a diode that we need to bring in and put in a spark gap? It may. I'll be very honest with you. It may mean that because we may blow some parts, but it does amplify the system. Now, Mike runs his on spark gap, so that's what the basis is in his Renegade device. And just understand what I'm trying to tell you. It's a voltage capacitor. It is completely designed for voltage, not amperage, not an amperage capacitor at all. It is a fast fill, fast discharge, which means it's a voltage capacitance. But that matters. So you can put the piezos in line with your negative in the circuit. You can put it in line with the positives in the circuit right there on the spike. Boom, we'll double the amount right away. That's going to be interesting. That's a whole test on itself. So once we have everything together, boom, we'll hit that and test it out. We may come up with, besides the device itself, like a little board that it sits on with the batteries and everything, and get, different things we're connecting into it. Just try to make it look as clean as possible so everybody can see what everything is. And I'll try to go out and label everything that we possibly can. For those of you who want to build this build, it's not going to be a whole lot of money like you think. I went on the Facebook Marketplace, got 2 rims for free, 2 aluminum rims, okay? Because somebody had went over and taken the brake and they couldn't get the bolt out of it because they let it rust in aluminum, and that's just a mess. So I didn't care about that. I just grinded it off. Didn't make a darn bit of difference to me. I didn't need the gearing anyway. So you get the rim out of it for free. Now, Sorry. The rest of it is fairly simple. I think my Amazon bill was like $150. Okay. The wire on it cost a little bit more, but I bought 10 pounds of it. So I probably overdid it. You only need 140 feet 7 times. So whatever that number is, plus one other wire of a different color, hopefully, because you don't want to sit there with your wire tester at the end of the day to go to end. Although you could, you don't want to do that. You want to use a different size wire, like 2 gauges difference, 2 gauges higher. Um, so you could do that. That's going to be fairly simple. That's under $100 for you guys. So this is a $500 project, I would say. You know what I mean? You can make it more expensive, but you can do it for $500. The piece of wood, one of the cheapest things, $32 over at the Lowe's, 12 foot by 4 foot piece. They have them in the little things. Now it's not exactly 12 inches across; it's 11 something. So watch out because they mislabeled things a lot. They try to them that little bit of the wood, it's a lot of money that they save. To us, it makes it chintzy and cheap, and they're a bunch of holes for doing it. I hate it. Just make the thing what it's supposed to be. But that's just grumpy old men talking. Anyway, that should be fairly simple. I mean, you could do it with a jigsaw, cut it out. Take a a piece of sandpaper with some glue on it, and just put it on a straight edge or I use a level sometimes. I can get that edge real fine. What I love was you go to the hardware store, the real ones, and they have strips of sandpaper like this, or about 1 inch like this, and you could just put it on the end of your level, on the side of your level, and then get a real nice flat surface on there. Anytime you have to angle something, just kind of a trick. You know what I mean? Some people have the belt sander. You know what I mean? And they like to use that, or they'll get one of those belt sanders with a round sander on it, and they'll do that, or they'll just take the belt sander and put a piece of wood in there on the belt itself. I've done that, and that'll come out and keep it real clean. You know what I mean, on there as well. Then paint's not that much. Of course, it used to be $20 for 5 gallons, and now it's like $20 for a quart. I tell you, man, these people, they just keep screwing us over. Anyway, like I said, under $500. I have black here, obviously, I painted my door, so I'm going to use the same color. Um, but yeah, that's pretty much it, man. There's not much more to it. The shaft will have to change in the main wheel. That's only because you need a longer length, and it has to connect to your fan. So if you got a 3D printer or something, put it in a little gap, part for the gap, not a problem. Just make one. Um, yeah, but it's fairly straightforward. The video that I'm gonna do on it, and I've been collecting all the stuff so far, is explaining things that you don't normally get. Okay, like everybody's seen him wind a coil. Okay, I'm just gonna give you all the specific numbers to everything. Okay, and I'm going to show you how the length goes, how to spin it, what parts are needed to spin it, things like that. Then we go on to the wood. I'm going to show you like I did in here with the picture. This is what the wood is. Here are the exact sizes of it, the exact pieces that you're going to need, the cuts you're going to need to make, everything. So you can basically blueprint this thing, and I'll put it in on a piece of paper when I do it, so that you have a cut list. That's fairly simple, right? And then we're going to just go on and show the basic circuit and how it works and everything like that. Sorry. But once that's done, you know what I mean, we'll show the cool stuff and how everything works and the other different parts and the things that I outlined here. I think that's going to be very understandable. And then what I'll do is, for all the members out there to my channel, to say thank you to them, is I'll give you a lot more detail on this thing. We'll do a few extra tests on there. We're going to go ahead and cross some different avenues that we probably may not normally cross, but you're going to see a lot of different things go on in this, and you know, we're going to make it real nice. So I think on both sides it's going to work out really well. But I'm excited about this thing, man. Like, you see these things on the internet all the time, and you don't always get a chance to build them. And thankfully, with this channel, I get a chance to build these, and I get a chance to show people how to do things and the quickest way to do it, you know what I mean, the cleanest way, what you have to get, because I didn't find a full guide out there that I liked yet. I don't know about you, but I'm kind of frustrated with them. You get one piece of it, and you get one piece of it, and then another piece over here. And I've watched everything Bedini did, man. And honestly, what 1 3 hour video would be enough to do everything on this whole thing, man, and just make a complete understanding of it. But in honesty, man, it's about understanding how the energy flows. And if you can understand that, then this is going to be pretty straightforward for you. So, really excited about this one. Um, so I do have a cool thing coming up. So as I bought parts for this, I bought parts for the Renegade as well. So, you know, Mike over there on the Faraday Research channel does the Renegade. And part of that buying that 10 pounds of wire is because Mike likes to use a lot of wire in all of his coils. So he likes a pound, 2 pounds. He don't even do it by turns, man. He just give me a lot of pounds. And so I bought everything for his as well. So the very next one after this, we're going to run right into the pulse motor and the Renegade. So Papa Bale, if you're out there listening, man, we're going to be coming up on some of your work as well. So that's exciting too, man. So I figured if we're going to do this one, we might as well do the other one. I have all the magnets for it. I have all the PLA to print out everything. I'll go on with Mike and talk with him and see if I can't get the STLs. If not, I'll just build them myself. And then coil's pretty straightforward. Mike already said there are 2 wire systems. He has a trigger and he has a main wire, but he runs it in a lot of wire. And then there's some tricks that he said he did past when he built it. And this kind of goes into his piezo and how he saturates each core that are on the outside. They're generally about this long, right? The trick to these things is saturation. So if we make them this big, but at a diameter they can do, so probably about a little over 3 inches, okay, right there on the diameter. But we want to keep it within 2 inches on the outside so that the core saturates and then disperses faster. Now, the piezo itself will double the energy to the core. That's the exciting part, the barium titanate. That's where it comes in. It's a saturation of the core, so it saturates it super fast. So you're able to pull out a huge spike out of that pulse motor. That's what I'm excited about on that one. And then, you know what I mean? We'll have that one done right away after this one. I'll just have to take time for the 3D prints to come out, but there's, past a wood frame or a little thing to sit on, there's not a whole lot to do there, but we'll make something cool. I think, man, we're going to have 2 examples of one a Bedini SG, then going into Mike's Renegade. We'll have 2 awesome examples, man, of just how this is starting to work. Now, we're going to have, after that, we're going to get into Tesla a little bit again. And I'm going to try to cram probably 6 months worth of information into about an hour on a video, which is, I don't know how I'm going to do it. I'm going to give you all the information on the 1 wire energy, all the multiple coils that I build, the bipolar coil. We're also going to get into the regular coil that I build. We're also going to get into the geometry coils that I build. And then there's a little surprise on the end of the geometry coil, which I finally figured out what I wanted to do there. And that should be good. So I think those first 3 months, man, it's going to be really awesome. And I'm looking at another build after that, and I don't know if I can pull it off in that amount of time. But if I can, it'll be awesome. But if not, we're going to probably go into Capazi. I still can't say the word. We're going to go into that coil, which is basically almost like a Tesla coil, and it's getting close to another device. Anyway, it's going to be working on basically the fields of it and seeing if we can't match them, pull more energy out, different values, stuff like that. So yeah, there's going to be some cool stuff on that one coming up too. Not a generally hard build to do. It just takes a little time and a little bit of understanding on frequency to get it right. We'll do that. So some of the things we have to watch out on some of these things, guys, is especially when we get to the Tesla coils, is radiation. And thankfully, I got a radiation meter for that. So that should be pretty cool. So there's another one out there. Okay. And it's a monopole motor. Now just think about this. They say a monopole motor pulls out amps. Okay. And yeah, Don Smith's work. That's what I was talking about. Exactly. So, sorry. Got tripped up there. Yes, Don Smith's work is exactly the one we're going to be doing on the month 4. That's the one I want right there. So the Don Smith, Caparzi, I'll figure out the name of it, man. I still can't say it. So that one, and then, oh man, I lost the whole train of thought of where I was going from there. Had a total different build in mind for the 5th month. Oh, if you guys can lead me back on it. Oh, monopole. Okay. Now, just think about this. It's basically a magnet, and all we're doing is rotating the magnet, but it pulls most of the amps out. Now, this comes into our research with our Tesla coil and the capacitors. It's the capacitors that you have to fill up, right? More amps means a faster capacitor fill, right? Doesn't mean you need high voltage and high amperage. No. You don't get those because they're a mix. It's a trade-off. Every time you do it in DC, every time you have high amperage, you have very low voltage. They don't change that. Okay. There's a few systems that can pull off both, but this isn't one of them. But the whole thing is, can you convert into the cap and get the cap to work for you? Okay. So high amperage, fill up the caps quick. So our capacitor choice matters in that experiment alone. Mike did that one as well. So if there is any mercury available, and I'll just say that way, I'm not going to go out and get arrested if they have anything like that or something like that. But if I run across some where I can get some, okay, I will put it on both sides, okay, of the monopole and pull in the energy that way. One of the things that you're going to find is the harmonic in the mercury changes things. Now notice I didn't tell you about the amperage. The harmonic going into the mercury is what changes the output of the mercury. Okay? Very simple, very easy understanding. It has to do with ultrasound and mercury and the way they work. So, when we do this, we may even go into a little barium titanate in that one too. The choice of material matters in all of these. Just understand that. If you're stuck on just copper and steel, things aren't going to work out as well as you want them to. You got to be able to pull in another material in order to get some of this stuff to work. So, yeah, you can get some gold in there, stuff like that, and you can use it to clean gold, stuff like that. But mainly, we're looking at it for energy. And so, when we do a monopole motor, a lot of people just get stuck on, oh man, it's got a lot of amps, but it doesn't got a lot of volts. That's okay. Capacitor changes that. Capacitor doesn't care. You see, this is the thing why we did capacitors last Friday, and I hope everybody got the understanding there. Capacitor is about fill time and discharge time. So it doesn't matter so much, is it high amperage or high voltage? It's the time it takes to fill it. So, and I'll give you an example of this, okay? This is where it drives people nuts. If I took a motor that had iron in it and magnets, right, along with copper. So I'm winding the copper, got the iron in there in order to saturate it to create eddy currents, okay? So I can get high amperage. That's where they come from, your eddy currents. So if I did that, you'd think, oh my God, you can fill capacitors, you could drive anything you want, right? You don't even need to fill the capacitor. You run it right off of that. That may be true. We'll just take a stopwatch to the capacitor. Okay? I'm just going to tell you a little trick here. But if I take the copper wire and I build it with an aluminum shell, and then I put magnets inside, right? The speed in which I can rotate that magnet is 10 times that. Okay? So the ability to fill that, it's very fast. Now, can I compare that with the total amount of power going into the capacitance? How fast is it going to fill it? If I can get close, then the answer is close. The answer is no question, I'd use aluminum every time. Less resistance in building something, but almost the same energy going in. I want that. And you say, well, Nathan, it's not powerful. It's not usable. It doesn't work for your load. It doesn't work for your load. You're not understanding capacitors. Capacitor is a field-oriented device. It fills as a field. Once you fill and saturate the field, that's all it cares about. It don't care how you fill it, what you fill it with, or anything else, okay? It is based on the energy and how fast it gets in there to make that field work. You go, well, then we're using the wrong thing sometimes to do this. Well, yeah, we are. Ones we use are cost effective. They're not the best materials. So you go, well, okay, so you just told us about bearing tightening. It has a very high spike when it comes to voltage. Oh, see, now you're catching on. Now you get to the point where you go, okay, maybe I need that in a small amount of capacitance before I get to a big capacitor, right? Now, again, capacitors matter. Fast fill rate, okay? Fast discharge rate. Going into an average capacitor, multiple ones of them going in there, now changes the dynamic. Understand what I'm saying here. You don't need to do conventional thought on this. You just need to understand what the capacitor is actually doing in the system. It is a field charge. As a field charge, it doesn't care what you put into it. Positive energy, negative energy. You can use the energy from the moon if you can get it. If you want to use radiant energy, you could do it. Anything that you could possibly get for an energy source, that capacitor will take it in and fill it up because it's based on something different than what you think it is. Now that we know that, we understand the conversion. We also understand duty cycle. We understand how to change the voltage in something. Man, it becomes a lot easier to start running these systems to see what's actually going on, right? So when we get in control of the devices, now we can run the right stuff. So just understand that when we start changing things out in here and we get to the monopole and you ask yourself, is it bad to have a lot of amperage in there? No, not whatsoever. It just means that we have to know how to get it into the cap the right way and how to charge it. Once it gets in the cap, it'll come out volts and amps based on the frequency and duty cycle you set it at when you put it into that part of the system. It's just going to act like a power source. And because we're going to put it in DC with a sine wave over it, we'll change it to whatever the heck we want. That's the point. We change it into what we want. Now, run motors, great. Throw it on a great duty cycle, and that way it goes, it hits it and stops, hits it, stops, hits it and stops. Great. We did the right thing. You want to use an AC motor? That's great too. Put a right frequency in it, okay? It'll rise and drop. It hits it and stops, hits it and stops. This goes to Edwin Gray as well. That's also on my list for this year. We're going to make a gray tube. Why would we make a gray tube? Well, because it's going to be basically like the other ones. And if you understood what we did with the Tesla coils, one inside of each other, and you understand why it pulled out AC, then you're golden on this understanding. Because then we'll have built a base already on what our caps do and how they interact, and you'll be able to see all that. But then going into Edwin Gray, that matters a lot because that's exactly how he did this, but he used spark gaps like Mike. So we're going to be able to pull it and put as much amperage in as we want to. Just understand this. Once you put a sine wave over this stuff, I'll bring the amperage right up. Okay? I'll take your DC and I'll put heavy amps in it right away. And it's a conversion. Okay. How many volts does it take to make an amp? Well, in a DC system, it's generally for every 1 volt, it's what, 0.2 amps, something like that. So I don't know, it might be a little higher than that. For every 20 volts, it's 2 amps. So yeah, I think 0.2 amps for every volt. And it works out. That's the exchange rate. So we just have to know that. And then our total volume of energy in our watts, and you have to watch out for that one because it's going to lie to you a little bit because they make the volts and amps worth equal and they're not. Okay. It's like saying, you know, I got Boardwalk and Monopoly and you got Marvin Gardens. Okay. Sorry, we're not the same here, buddy. It's not at all. There's a difference. So if you calculate it properly, then you'll have it. Now, there are some cool things, man, that come up inside these coils that, you know, I know dead fish out there would like. They put quartz in the center of a wound coil. I just understand this as a core to make it run. Okay, because it automatically bounces back and forth. It's doing the work for you. Now, if you put it on a coil on each side, it's doing the work for you. Just like this. That's pretty cool, isn't it? The Baron Titanate will do the same thing. Listen to that name. Go look up the feed energy devices you've always talked about. Yeah, it's going to work. You put that piezo transducer between 2 coils, gets the oscillation. You put quartz in there, does your oscillation rate, okay? Some of these things are meant to go together that we don't put together right away. We're going to. It's a different understanding, guys, that most people ever get. That's why I wanted to do the builds in this particular manner, because I think it's helpful that we see every little bit. Because a lot of times, and I know I do this, I go online, I look, maybe one guy's doing one thing, and then, you know, I mean, there's a lot of testing in there, and then he doesn't make a video at the end for a real clear shot of everything. And I do that sometimes myself. But I'd like that. You know what I mean? Once a month, a big clear shot of everything. And I think that's the way to go. That's why I want to do it in this particular manner too. Yeah. I can tell you right now, there's a lot of things about crystal most people won't understand. They don't have it yet. They don't understand why things work the way they do. I think a lot of people in the audience here knows that's a big part of what we do. And it's because of the way it's built out, the geometry, the frequency, and everything like that, and how that all works in the system. I could tell you this, man. A lot of the stuff they say is woo. It's not. It's not at all. They just don't understand it. Let's put it this way. Let's take a UFO craft, right? If they tell you that there's 1,000,000 volts to lift it, or it takes 1,000,000 amps to lift it, they didn't learn their lesson on coupling energy at all. Okay? The brute force method is 1,000,000 amps or 1,000,000 volts, which means that you're dead inside. Don't even bother trying to get into it. You know, it won't work. But coupling's different. You see, coupling energy is how you use the environmental energy. That's the big thing here, guys. Just understand what I'm trying to say to you. It seems like it's a low energy level. And you hear this from T.T. Brown. Always seems like it's low energy, but what is it really? It's coupling fields of compression. So if I couple a bunch of fields in compression, what happens? My energy looks like it increased. We're not creating energy, we're coupling it. We're using harmonics, we're using frequency, we're using resonance in order to couple these fields. It's way more powerful than you think. It's going to beat your brute force method. So instead of 1,000,000 volts, oscillations 1, there you go. Instead of 1,000,000 volts, we're looking at 30 volts, maybe even 12. Is that insane or what? And it all comes down to that because a lot of people think in the wrong way when they think of energy. they still think, oh, it's a closed system, so your power supply is 12 volts, that's your battery, that's your system. Well, it's not. Remember this when I tell you this. You have to account for everything. It's about accounting when you do this. If you have a closed system that's on a battery, but you have an open system to the environment, you're now having the ability to put in the 12 volts plus every bit of energy in the environment. You know how many joules of energy are in the environment? Yeah, a massive amount, which means that our little copper setup, remember, you can't create or destroy energy. So in a generator, you're not creating energy. You could tell me until you're blue in the face you are, but you're not. You're pulling in the energy. Once you realize that, you go, well, where am I pulling it in from? The next logical question, right? Where am I pulling it in from? Well, the environment itself. You say, well, that's pretty interesting. That's well, now how much more can I pull in? Well, now you got to the right question. What material do I need to make it pull in more? That's why I use the barium titanate, because now we can double it. Hey, there's the first start, right? That's kind of one of the understandings I want to get people to so they can understand. And when you couple fields, man, is it a game changer for you. I had to learn this one the hard way. The RAV couples fields, okay? Very low energy input, but it couples fields. So it has a ton of energy inside of it. It's a small, so it's a certain locality for the energy, but for the space it's in, it's huge, okay? One of the things about understanding energy that comes into this, we don't do things the hard way where I'm at. I have no business putting a million volts or amps into something. I think that's ignorance. And I wouldn't even bring it to you. I wouldn't even do the calculation on it because I know that's not the way it operates. And you say, well, how do you know that? Because we're in a sea of energy right now and it's not very strong. They always say it's very weak. They say you create an EM field and it's stronger than the energy that you're standing in. And you go, well, that's only because of the size. The size of this is so big versus the little field you have. That's why. And then you start to realize they coupled the fields on the outside and you go, oh, hold on. That means that I don't have to have a very high amount of energy to couple fields inside of this zone right now because it's a very weak zone. And now you get into it. One of the things people also don't understand is the earth has every mineral in it. Just understand what that means. If I tell you there's copper, there's zinc, there's gold, there's silver, everything runs at a different rate. Everything will produce a semi-different energy. You go, well, Nathan, there's a ton more in there, right? There's, cobalt in there. There's a bunch of stuff we also have. Okay, so what's the problem with coupling with the field that you're in right now? You're not realizing what it's made of. It's also a crystal oscillator in there. Now think about what I'm trying to tell you. If every one of those has a value system and you have to get on the level of those value systems, are you ever going to be able to control them all? And this goes to the simple test of, I'm going to drop a magnet that's circular, or I'm going to drop a piece of iron that's circular, right? Which one drops faster? Well, the magnet will interact with the environment at what, 1%? So it'll be about that much slower getting to the bottom. If they're exactly the same, the energy drops to the same time and they're conserved. What is that telling you about the environment, though? It's telling you that you're not in contact with all the fields in the environment because you're not producing all the environmental fields. So you go, well, man, that really sucks, doesn't it? I mean, how can you control all of them? I mean, or how can you pull up the energy to get to all of them? I guess the first question was the right one. It isn't about locking into each one of them. It's controlling them. And think about that. Let that sit in for a minute. It's about controlling the actual energy itself. What devices control energy? Frequency, harmonics, oscillation rate. Those are things that you can control on the backside of a system to control the main system, especially if it's open air. Think about it. If I wanted to change my Tesla coil and I have a Slayer exciter on it, it's very vulnerable with only two parts. If it has a resistor and a transistor, and I put no other part on it, nothing to reinforce it, it can now couple with other fields and be changed. Well, you're just changing the frequency of it, Nathan. That's what you're doing. It's high voltage leaching. It's using the open air environment in order to change the frequency. Yes. But when I changed the frequency, I now coupled the field. I now took what came through a source of gold, and then I took what came with a source of silver, and I now combined them on the frequency. This is kind of where you get into what the heck did you just do? You see, I understand that I can't control all the energy sources, but I can damn sure control the frequency, the harmonics, all of that. Now you go, this is where the woo factor comes in big time. Okay, just understand this. Once you understand that, then you understand what the monks did. You go, man, they moved that rock, right? And they got anti-gravity out of it, or what? Anti-gravity is a myth, by the way, the name, in the way the name says it, not in the act. But what did they do? They found the sources that combine the energy in that particular rock. What is it made of? What frequencies can control enough of it to make it work? They put it in a bowl for a reason. They wanted the frequencies in there to be harmonic. Just like when you take your finger on the outside of a glass and whoo, right? You get a nice frequency out of it. Well, they're going to create a resonance in there. What is that going to do? Well, it's going to get it to the point where it's got filled with energy and it can't tolerate it anymore. Okay? Then they're going to spike it. Now that sounds simple, right? But what are the actual physics behind it? You take a DC wave this way and an AC wave push back on it. Okay? Square waves create a pyramid structure, a step pyramid structure. The AC goes over top. But when you cut off half of it, it's a pulse DC. All three of those waveforms are necessary for anti-gravity. All three of them. It is an oscillation between them all. Once you create that and you create a saturation in an item, it moves. You say, well, have you ever seen something like this happen? You go, yes, I have. So I did a little paper lifter experiment. I go, a little UFO paper thing, right? Something silly and stupid. Has an anode and cathode on both sides, okay? And one's bigger than the other, one's smaller. But the thing you're trying to move is paper. Paper has no business moving in an electrical field, right? It's a non-conductor. But if you saturate it with very high voltage and very low amperage, it now can conduct energy or hold it in. Because of the mesh on the top of it, okay, on how it's built crosswise, it holds in energy. Now it'll lift up in that field. The same way aluminum will. You go, wow, well, that's not supposed to happen. That's like taking a tree and lifting it. Well, on a small portion of it, with the amount of energy I have, yes, it is. But it also means that some of the things that you think are non-conductors are actually will be able to hold in energy, no problem. You know, Sean shows that all the time. He goes, okay, this little piece of plastic right here is an insulator, okay? And it sits on the outside, so it's not going to conduct at all. But then he hits it with enough energy and it gets to the point where it starts glowing. And you're saying, well, why is it glowing now? Well, because it's saturated with energy. You have to understand it in the way that it's given to you. Saturation of certain things changes the function inside of them. What does that mean? It means that the resistance is leaving the item. It means that you're going into superconductivity. How do you get to superconductivity? You have to take away the amperage in the item. Anything that has amps in it has to go away, and you got to create as many volts as possible. Rarely do you get to the state where you have way over top on the voltage and 0 amps. I've never seen it because they're coupled systems. But you're going to get real close with a lot of items. I mean, a lot of them. And once you do, you'll understand saturation rates and then how to do things based on that. This stuff, man, it's a lot different understanding. We're coupling fields. We're pulling frequencies on the outside in order to do it. Yeah. Yeah, you're absolutely right. Acrylic will. Absolutely will. Paper does the same thing, man. In a electrostatic field or a high voltage low amps situation on two DC flybacks connected together, you get paper to lift right off the ground. That doesn't seem right, but it is. You're making a capacitor when you're doing anti-gravity. I'll just tell you the very honest truth here, okay? And you're going to find this out for yourself. If you listen to Sal Paez or anyone else, there's a reason they allowed his patent to come in, and there's a reason why it works, because T.T. Brown already did it. This is not something that was newly invented. This is all T.T. Brown's understanding. It goes back to Tesla and the things that he did. Otis C. Carr understood it as well. Okay? We just get this out. Otis C. Carr understood something that rarely people do. Okay? And it probably came from Tesla. The air is your capacitance. What does that mean? We take a neutron coil and put it in the center, right? What fundamentally changes about that is it changes the energy to a pulse DC as soon as you did it. You didn't realize it, but that's exactly what you did. You put it in a pulse DC. What does that do to your field? Well, it goes around to the outside and you have all these different coils out there, right? Well, you get shared capacitance between them. The center goes out, goes over to each one of them. Capacitance happens in between each coil because you have your regular magnetic field, but then you have your dielectric field in between them. In between each cylinder here is that field. That field couples along each one of them in a certain pattern, and then it allows the capacitance to stay at a very high rate inside there. So what happens to the main energy source? The main energy source is drawn down in the system as the frequency amplification goes up. That basically means that whatever your trigger voltage is on your main system, that's how low you can drop it. If you have a 0 trigger voltage, buddy, you're getting into over unity. If you have a 3 volt system, it'll go down to 3 volts. Okay. If it's 5 volts to trigger, it's going down to 5 volts. Does that mean the energy is different? Absolutely not. The energy is actually higher. You say, well, why? Because it's coupled in capacitance inside the air between all the coils. Therefore, it does not need to have a separate capacitor for it. It's already built it in the air. That's what Otis C. Carr understood. Why does that work with the environment? Because now when you get up to a, what is it, 100 volts per meter, and you get up in a high environment, it means that if you take the outside of your craft and you make it into a high spike material, okay, just like the barium titanate, you're going to be able to spike the outside field there, okay, because it's what? Mostly voltage. You're going to spike that right in there into the capacitance you already have in the system, buddy. I'm sorry. You got an over unity system right there. That's why he said it was, because it was. Interesting, because they use frequency to get there on all of it. Frequency is not difficult. You just have to understand it. Whatever the resonance frequency is the same amount you wind in another coil, regardless of the shape. Think about that. Regardless of the shape. That means that you can have neutrons. You can have cylinders. They're going to act together. Get your frequency right. Make sure it resonates right. But that's an over unity system as soon as it hits the air, because when you get up there, it's a very high voltage system, very low amperage system. But we'll get on to the other devices, man, and stuff like that. A lot of anti-gravity, what it actually is field coupling. Now just think about this. There's two systems that have to operate. One is propulsion. The other is you have to create a gravity well. If you don't do both of those, you don't have it. Okay? You have to be able to do both simultaneously, which is fairly easy. You think about the way the gravity flyer runs, it puts out all the correct fields for you. It just doesn't put them tight enough. You got to be able to tune it to tighten them. And God, if you could see it, man, it'd be just seconds to tune it. But you have to go by listening and other methods because we don't have the right one to see them yet. But that's it. That's the outside field. Now, why does that work? Because it causes a different field on the inside versus the outside. You're structuring all the air around it. It tells you right away. Radiation structures air. As soon as you put out the fields, they stop at a certain distance. You can put out a light bulb. You can put out a radio on the AM side, and you can find the actual spot where it stops at on each one of these individually. No problem. You can put out sensors in there in order to find out where the fields are. The whole part is, can you compress them well enough? Well, it means you have to be able to change the frequency in all of them in order for all of them to work. Therefore, they must be in an open system somewhere where they can cross each other so that they can get in line with each other. That's why in the little bottom of the gravity flyer, you have this little panel on there, and you stick your high voltage in there, and you put your Tesla coil one in the center. It saturates the other two, so it means the distance in the field shortens. It means that it's able to now compress. Now the inside compresses. What did we learn about the environment? The environmental energy is less than an EM field. Why does that matter? Because as soon as you go into compression, now we start to get into gravitational effects. You see, that's where it comes into the whole thing. Compression, rotation. Do you have the field right? Okay. You need all of those things. There's no question about it, but a gravity well is simply that. It's the compression of the fields on the outside compressing to the inside, regardless if there's a center point that you made or not. Understand what I'm saying? Regardless of a center point that you think you made or not, it will make a node by itself. It is not something that's contrived. It's very well known. Okay? You're taking this gravity flyer and making it into basically a Tesla coil, and it's going to create one right in the center. Why does it take 3 plates? Because that goes into your propulsion. You want to get buoyancy inside this thing, right? You want to be able to get to propulsion. Well, there's nothing against buoyancy in the air. Nothing. No system out there tells you it's not possible. They'll actually tell you it is possible and it's the way to go. Why? Because once you make this bubble around the craft, just understand this. Go outside with your kids and blow bubbles. Okay? Sounds like the stupidest thing in the world, right? Go out and blow bubbles. Ask yourself, does that bubble have a field direction? Or does it just wander aimlessly? Is it floating even though it has weight? Why is it floating when it has weight? It's going to drive you nuts. You're going to go, well, it's so small, it doesn't matter. Well, then throw an ant in the air. See if he floats. If that's your answer, go ahead. An ant come right back down to the ground. He don't weigh nothing, just like that bubble don't weigh nothing. But the bubble is doing something different in the environment. It's interacting with the environment differently. The ant, he's going to be very pissed off at you, okay? The bubble's going to float. It means that once you create a field bubble around something, it means that it doesn't have a direction, but it's still sitting there. It won't show you one sign that it's anti-gravity because you have no propulsion. You may have something that's anti-gravitational and there's no propulsion to it. Now, is it actually pushing against gravity? No. That's a misunderstanding. It's coupling a field inside of a field is what you're doing. Not anti-gravity per se. It is creating a field bubble in order to make your own gravity. So when you get to the other part, you have to have a direction. Now think about this. If you took It's probably the easiest way to understand it, but it's still difficult. If you take Otis T. Carr's device, and you got the coils on the outside, right? If I want to get a direction out of it from the center, and I want that center to burst, but I want it to hit one side harder, how do I do it? Well, I basically take capacitors and then I detune all the other coils except for the one that I want to hit. I put energy on the neutron, changing the frequency in the capacitors that it goes into to the Tesla coil, making the outside detuned except for the one that I want to hit. And as I have that energy increased in the one, plus the center coil, I now have directionality. That's probably the easiest way to see that. It's still difficult. You still have to understand. I just detuned a bunch of these coils just using this little neutron that's over there spinning because it's my frequency in the device. What am I going to do? I'm going to use those coils to slow it, change the frequency in the coil, take them out of the picture, take the one and identify it, make it the one that I want to hit, and then boom, I'm going to drop the energy right through the center and it's going to hit harder. Why? Because the resonance in this is going to match the resonance in this, but you have coupled capacitance to go between them, so you're going to get a vector direction. Okay? That's interesting. But it also works on flat plates. If you've ever made the ghost in the machine device, which is just the little two plates and you made a little ghost in there, you realize that as much power you give it, he'll jump. He'll stay in the same general area, but he'll jump. You're creating a directionality when you take charges on plates. I'm sure a lot of you haven't seen this yet, or maybe you've seen it. There's a video out there where the guy deals with charged plates, and he's got this little lab coat on and stuff, and he's talking about his lifters. Well, it's always the same way. He takes his little small one, he takes his bigger size one, and he's getting him to go a direction, and he goes, every once in a while it'll flip to the other side. There's something very important about that. Because it's the same thing Alexi showed you. Stick, fence, touch, 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 boop. Has to do with charged surfaces. Once you create a charged surface on one side, now you can create a direction. It's the reason why you got to do that. That's why the top one, it's further out on the little wire. So as the plate goes, it'll tap, 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 tap. On the bottom one, it's close in, so it stays. All times. You think it's something that's you think it's something that's not right. It is. Do you believe Bob? Are you talking about Bob Greenyer? I like Bob Greenyer. I like his work, but I don't know if you're talking about some other Bob out there. But yeah, we can create. It's just not anti-gravity. You're not creating a field to push against the ground. Bob Lazar. He's been right about a lot of stuff. Okay, I'll explain this. Okay, is there two types of anti-gravity? Yes, a weak one and a strong one. A strong one is coupling fields. A weak one is high amounts of energy. I guarantee you no alien civilization is using the second one. Brute force is something that's totally different. Okay. In methods to create anti-gravity, John Hutchinson was using brute force. We're using field coupling. Though I suspect John was turning down the energy levels towards the end and getting a lot more field coupling. And I can tell you that just by the simple experiments that he does all the time, even today. The AC and DC coil, I don't think a lot of people understood that. He takes a Tesla coil, puts an aluminum ring on the top, and it jumps. What did he do? he created one of those what do I want to call that? Not the gray capacitor, but the oh man. Anyway, he created that. That's what he did. So basically, it's a coil inside of a coil. You see the other coil wrapped on the outside. The DCs that went back and it created a DC pulse wave, which is much stronger than an AC form inside of it, and it'll make aluminum jump like a mother. So that's what he did. He understood it. He understood crystals for oscillation as well. Why do you think he was making that crystal stuff that he was working with? He understood one wire energy because that's how he changes his plants inside of his house in order to grow different things like that. Bob Lazar, with the two different kinds of anti-gravity, is absolutely right. Is it anti-gravity the way that we would think of it as in pushing against the ground? No. And he's right about that too. He's 100% right. Element 115, 119, whatever it is, honestly, it has to do with Mercury and the way Mercury works inside of a field. They won't allow you to work with Mercury like that, by the way. It's illegal. You know that, right? They don't want you working with Mercury at all. There's no games about that, guys. That's what they don't want you to work with because it manipulates things. Mercury's like a base, and when you hit it with high ultrasound, it changes. But it also is a great conductor, and it's the correct answer. It's one we will never be able to play with without the government coming down on us, and they'll shut you down quick. The element that they were using in there was probably red mercury. Okay? Could be wrong, could be right. It could be because the element that they came up with that matches that number, and I think they believe they did it in Russia, is a volatile element that is not well contained inside of a system. It goes away too quickly, explodes or expands or something like that. Wasn't exactly what they thought it was. But this goes back to, did you understand why you use certain things? Why do you use aluminum, bismuth, aluminum? Well, because you're going to get convection inside of a field that's one on top of the other. Okay? If you build a coil this way and I build a coil this way, okay? What do I want to do? Amplify the, you want to amplify that on the outside, right? The convection. You want to amplify the convection. That's why it works. Because it's in lead form, but then as soon as it starts to melt, it'll become a liquid form. Why does it work in that way? Because of the temperature itself. As soon as you create convection in there, it then liquids out and starts behaving like a mercury inside that two shell system. It doesn't stay lead. I think that's a misunderstanding of people who take this stuff apart. They think, oh, it's going to be, the bismuth is lead right now, and I don't understand why. Well, why is it not bismuth? Well, it's because it melts in the inside between two aluminum plates based on the convection going on inside of it. That's why. When you get to some of these other metals, just remember that as well. Those are the metals when you start hitting them with high frequency and stuff and you get to ultrasound, then they're going to change as well. They'll all change how they behave. So that's why the metal research is important. I mean, we got a ton of stuff, by the way, about this stuff. Yeah, gallium and cilium. Like I said, they'll all change because gallium's real fast. It'll liquefy real fast. If I'm not mistaken, we're very low on the temperature scale, 100 something, 200 something C or Fahrenheit, and it melts. Yeah, basically like a butter stick. So, yeah, that's fairly easy. I mean, but on the other side of it, you have cobalt, which it doesn't take much to get it to a superconductive state. If you're flying through space, that's what I want all of my transformer is made of in the core, because it goes into a superconductive state at a very low temperature. I don't mean that as a freezing type thing. I mean that as in, it's not hard from the normal, point of zero we get to. There's a lot of reasons to use different materials. But I'll just tell you about gravity in the last little bit of this. I keep saying it. It's not what you think it is. It's a field bubble in order to make a gravitational field inside of your craft. That's as simple as it gets. Now, will that show up in any way? Not really. The propulsion shows it up. And here's a theory to understand this, okay? Build a coil inside of a coil. Then take a magnet and put it under it. Jump one coil for one frequency, it goes this high. Jump the other coil to a different frequency. It's now up here. Remember your magnet's down here. It is not coupling all the way up here. It's coupling here to here. What does that mean? It means you're a bubble on top of another bubble. You've already risen because the frequency's different. You've already created a bubble somewhere. Hit that with pulse DC and it flies off. There's an understanding there and how to create a field and then how to move the field. I think everybody gets stuck on everything else. That's one of the most important events there is. If you took, go out and build yourself a bunch of magnetron or magnets, right? Gotta get you a bunch of microwave ovens, tear out the transformer in it, make them into giant magnets, right? If you're able to take a aluminum coil and get it sit this high off it, right? Because they'll basically work on that. Change the frequency and see if it jumps. Get yourself a field bubble. Have something float there in the air. Get yourself a field bubble and see if it'll jump. Then turn off the magnets underneath it altogether. If it stays in the air, then the problem you're having is you didn't properly create the field bubble to the ground. You didn't make the ground magnetic. And you go, well, Nathan, how do you make the ground magnetic? That doesn't make any sense. Sure it does. You see, when you deal with one wire energy, you put the energy directly into the water table. When you do that, you can change the energy itself because you could change the frequency in it. Now you can make that magnetic. You can give you your first lift off of a bubble underneath. It's not terribly difficult. We already do it with one wire energy. That stuff feels like uncontrollable, but you got to remember what's inside water. Water's going to give you the ability to have frequency inside of it because it's structuring the water, whether it's opening the pores up or whether it's in positive and closing them down, you're still playing with the frequency of it. You could now create magnetics in it. Well, it does have everything to do with gravity. I'm sorry, Eighth. That's where you're wrong. I'm 100% right in this one. 100% right. That frequency and how it jumps matters a whole lot. What's going on, Papa Bale? Wow. I just say this, there's a lot of stuff, man, that I have created in here that we don't always see, but it works. So, yeah, I'm excited, man. We're doing some cool stuff. Yeah, we're building a motor, man. So, Papa Bale, next month we're doing the Renegade, which is a pulse motor just like yours. We're doing Bedini first, which is the SQ. Then we're getting into the pulse motor, which is the Renegade that Mike built, which is just like the pulse motors you're working with, or shared, shared medium, I should say. So yeah, we're getting into both, man. So we're gonna have a lot of fun, man, and be able to go back and forth on techniques on how to build things. So I'm really excited about it, man. One of the things I was sharing earlier is Mike says he uses piezos, and There's barium titanate in the piezo's electric disc, the ones he gets the big ones, okay? And what it does is it's a fast fill, fast discharge capacitance that's able to get into them. So that means that if you're looking for something to take your coil and saturate it real fast, okay? Real fast, and then pull it directly back out. That's exactly what they do. So think about the pulse motor and the way it works. The magnet hits it, you get a saturation, and then it comes back out of it. Well, what happens now when you do that, but now the amount of saturation in the coil doubles. It doubles because the way that the barium titanate works as a capacitance. It goes in there and it doubles the actual frequency of it, which will double the voltage in it without changing the amperage in it. Now we're getting somewhere. That's why he's using the piezos in his circuit to do that. Let's see. Did you see the shockwave motor? It's like a turbine flanging its fins, and each then is tuned to stroke of the intake exhaust. I have not seen that one. Yeah. Notice it in parallel like an echo. It's that saturation rate. That's it. That's all it is. It saturates core faster, and it doubles the frequency, which doubles the power into it. So it's basically, if you've ever looked at your oscilloscope and you got a line that looks like this, it takes that line and drives it like this. It means it just jumped your power a whole lot. I found that very fascinating because I was doing it with my jewel thief circuit, my gravity flyer. I didn't really realize what I was doing. Think about this. If you take a jewel thief circuit, you saturate a little core, right? This little round core like this. And in that, when you have a piezoelectric disc, it's taking the frequency itself from other things and charging it up. Well, this thing was pulling in a ton of energy really fast. Okay? It was boom, fast fill rate. This thing was charged all the time. You push the button to turn it off, and boom, it just busted a bunch of energy onto everything. Yeah, that one's kind of cool. One thing I will say is if you mess with a piezoelectric disc and you're trying to harmonize fields or get the fields to interact with each other like that, you're going to want to check out why hearing aids can hear it and you can't. That's what you're going to want to figure out. And it has to do with the microphone suppression of things that you're using. And once you figure out that, I think it's a $140 mic, if I'm not mistaken, that allows in all of it. You're going to finally hear that thing scream like a banshee. Okay? Your regular microphone's going to cancel everything out. If you wear hearing aids, you're going to hear it all day. I can tune that sucker by ear with no problem whatsoever. And I'm mostly deaf, legally 80% deaf, but I can put in my hearing aids and tune it with no problem. Ultrasonic frequencies work a little bit different. Huh. Yeah. So one thing we do have going, guys, and I realize this, just go back to the Bedini. I'm using 24 gauge wire, and I'm using 26 gauge wire as a trigger. Bedini towards the end was using 20 gauge wire as his primary wire, and I believe it was 22 gauge as his trigger. I'm going to get there on my second coil. Okay. I have my first one built. I learned how to build it. A lot of wire. Okay. Now I know exactly how much I need. So I'm going to build my second coil the way he did his. I want to know why he switched. Okay. There's got to be something in there and why. Because if you have smaller wire, more winds around a coil, the magnetics changes versus larger wire. There's an understanding there. We're going to have to figure out why. Okay. I just know that sometimes it makes it more magnetic or quicker to a magnetic field with thinner wire, but then he went thicker. So he must have saw something in the opposite effect that was more advantageous for him. So we're going to have to do that and show that because it's going to be a nice understanding. Yeah, Papa. Yeah, it's bursting. Yeah, it's total different, man. Totally different. Oh man. You're about an hour behind, man. We covered a lot of things. Oh man. You know, you said 20 is in the middle. Nice. Okay. That means that you're using a lot lower gauge of wire too. That's cool. I remember I thought I heard something about that. A 14 gauge or something like that. Not too heavy either way. Got it. Yeah, oh, that's one of the other things is the bifilar Tesla coil. So we use the Odin coil here. You know, we call it a Tesla coil. Old school Tesla coil. Charlie, she asked me to build one, and I've been working on one. The hard thing is the field underneath the field here, because they're not compressed well enough, without super high voltages, those don't really work. So then they use frequency generators and run to run a number two coil. I guess, but that's not real oscillation. There's the third one where it's the outside windings there, but then they do an inner core that's a winding as well. That's the one I want to focus in on because I think that's the one that's going to work without getting crazy voltages because you don't have enough field to saturate with the voltages we have. You just don't. So some of those Tesla designs don't really work that well. Another thing that I want to do is the flat coils. Now, we always call it a bifilar coil, and we see it's flat, but we build it with the wires like this. Okay, I want to build it with the wires like this, and it's just because Tesla did it, and that's going to be one of the builds for the month, and then testing that out and see what happens. And what I think people are going to learn on that one is just how capacitance works in between two coils. So, pretty interesting. 221 boss told me that to put the disc in my Bedini build, the disc in between the coils. You want to if you take a piezoelectric disc between the coils, you'll be able to put a oscillation between them, and you can get it to self run. Oh, one other thing, Floyd's Suite. That's on the list for the end of the year. Okay, and it goes back to the Tesla thing. If I can pull this off, we were talking about it last week. Okay, what's so important about counter fields? High voltage, high amperage. It's the only way to get it. The only way to get high voltage and high amperage is to cross the fields. One wound this way, one wound this way gives you high voltage and high amperage. Think about that. You do that, two round spherical coils with a number one on the outside that goes like this, you can change a lot of stuff. That's why it was working. It makes a high voltage and a high amperage. And yes, there will be some canceling going on. It will change the way the field looks. It'll go more like a mushroom cloud on the top and a mushroom cloud underneath it. But isn't that what you were looking for the whole time? Just saying. I couldn't believe it. I'm over here listening to ChatGPT tell me, no, you don't want to build in the same wind in the same direction. You want to do it opposite because you're going to get a higher value. And I go, okay, well, how does that work? And then they tell you, and I go, oh, well, that kind of matches a little bit when you take one coil wound one way and then one coil wound the other way inside of a coil, but you're not getting everything you need out of it. But now once it turns a little bit, now you are. Now it starts to make sense in what's going on in the gravitational field of our planet. There are fields being swung that way all the time. We see it probably in the wrong way. We see most of it going in. We know that we have vortexes, both sides. We also, if you look at it, we have a diamond in the center. I don't know that it's exactly a diamond. I think it's going to be an 8 that goes in there. Can't even draw an 8. It's like that. Okay. And it has to do with the way nodes work. Okay. I think it's a dual node planet, is what I really think what we're dealing with here. So it'll create that. Now, it's because of the way it pulses back and forth. That's why I think you have it that way. You're going to get an oscillation inside of the crystal itself towards the core, because the first thing that high voltage and plasma builds out is crystal. So you're going to have a lot of crystal formation around the core, which, by the way, um, I don't know if anybody really understands this. The only thing you have to do is stress the quartz, okay? And I'm sure you hit a lot of times people go, you got to just compress it hard enough it works. It's not so much that. It's like a high stress that has to be put into it, which is a bit different than just putting your drill bit into it, okay? Which means that you could take a piezoelectric disc, put it on the side of a piece of quartz, and it puts high stress on it, okay? But when you put the RAV in there, it's putting a high stress around it anyway, okay? Because, again, compression. Compression is the key to high stress. Compression means that once you compress it, it doesn't take much to pull the switch. It takes very little anti-pressure to do it. Think about that. It's just a little bit to tap it. That's why at the core of our planet, we have a bunch of that. But then it goes through all the minerals on the outside. And you go, okay, well, there's veins of copper there. There's veins of, well, whatever, silver, anything like that. Well, then those all create fields. So all your field lines, if you want to think about it in a real simple, basic way, which not exactly the way it does, but it's a simple way to understand it, it goes through the vein and creates an energy source. So, oh man, I hit a bunch of gold, so it creates an energy line, right? Then I go over here, I got copper, I got an energy line of copper. Okay, things like that. You got to think about them. They weren't lying to you, by the way, when they tell you in the periodic table, on the Russell periodic table, that you start changing the frequency and things, you'll change the structure of them and go between, copper and something else. The problem is what they don't tell you in that is it has to deconstruct the material first in order to remake it. You can't take a hardened structure and make it into another hardened structure. You must first break it down. So where do we see that? Bedini transmutation, sapphires. When he did that video, what did he do? He made it into a paste, then reheated it into a solid. Think about what Bernie does with electroculture. Makes it into a paste, then he's going to have to reform it into a solid. We saw Sean do this with frequency from high voltage on glass. It twists the glass and makes different shapes in it. What is the key understanding there? Once it's broken down to its very low, thing, it's just mush. We're just going to paint it on top of something and hit with a high voltage over top. We're going to structure it. We're going to crystalline structure it just like that. We're going to nano coat the hell out of things. It's kind of a lot there, but it's definitely there. So, yeah, one of the other tests is seen is once we get those coils built, the Tesla bifilar coils, now we can take in there and we can put in a DC field, okay? And this is going to get people. We'll put in a DC high voltage field. And you go, well, Nathan, I've done that and it doesn't do anything. It sits there like a bump on a log. It's not doing anything. We're going to pulse that sucker with DC, okay, with a pulse DC, okay, and a pulse AC and see which one wins. What's going to happen? There you go, Lorentz force. You're going to get that aluminum to jump. At what feels like nothing. Why? Because you got to remember, it's an actual capacitor that you're filling. What I tell you about capacitors, it doesn't care how you filled it, But then you can change the value of what the capacitor is by changing the field inside of it. Think about that. I filled it with DC real fast. Okay, real fast, a real fast charge rate. If it was high voltage, of course it's going to go fast. But I saturated it fast. Now I'm going to give it the energy that I want to give it. I'm going to take the other wire and pulse it. This is the kind of understanding we're going to get to, guys, in capacitors. It's not just hook it up in the system based on the value of the number. That's going to be out the window. You know, they say DC doesn't have a frequency, but you got to understand something about DC. It does have a height. The height represents the frequency in the system. It gives you a total value of voltage and amperage that goes in your system. You say, well, total voltage, but that means that it must have a frequency, but that's the way they see it. They see it as a height. Well, what happens when I add another height to it? We said, well, now I got a frequency, I have 2. Well, how come you didn't have it at 1? This is a misunderstanding, and they do the math, and the math works out, okay? I'm not going to disagree with that. What I am saying is then you put frequency over top of it, and it changes all of it. Completely changes your understanding of how these things work. This is what being a master of electricity is about in these small systems, is you really get to understand every bit of it. You get to understand batteries work different than the wall plug. Pull the negative on the battery. Okay? It's the way DC works. Not exactly told you that way, but that's the way it works. It keeps it cooler. What are you trying to do to everything in the environment? Keep it cooler. So at all times you want to use the temperature in every system. Yeah. Controlling the temperature in the system is everything. You don't want things that set off that DC to go like this. That's the last thing you want. Notice I didn't go down to here. You weren't turning it off. You were adding extra and taking away extra at the top. That's the last thing you want in your system. That causes all kinds of problems. All kinds of heat problems in your system. You want to get it more efficient, get rid of that. How do you do that? Take a diode, put a capacitor over the diode. That doesn't make much sense. Well, it does when you know what a capacitor and a diode is. What's a resistor? It's all the same thing. Okay? Here's a easy way to come at it. Okay? Make a high voltage capacitor. Put a magnetic field in the center. Okay? What happens? Well, the amount of energy that goes from the center to the outside goes in one direction. Why? Because the outside can't saturate enough magnetism to push it back the other way. So you have a diode, right? Then you say, okay, but then it pushed the voltage up and took away a lot of the amperage because of the field. That's correct. Now you have a high voltage capacitor. You know what? But now, if I want a resistor, all I have to do is take the wraps on the outside and lessen them. Say, well, why would you lessen them? Because at a certain point, I want the magnetism to be able to saturate the outside of those as well. That means that the amperage can pass. So now you have a resistor. They can all be built in the exact same form. That is the craziest thing in the world. You could take a magnetic center, wrap aluminum foil in clear plastic, just like this, and at different sizes that you do it at, you get different understandings of each, but they're all built the same way. What does that mean? As soon as you started playing with how many layers that you put on the outside, you change the frequency of it, okay, which usually means that you raise the frequency and lower the amperage. Okay, but if you needed to get to a certain voltage to lower the amperage, then you put in a certain resistor, right? This is why you can use coils instead of all the other parts and then get away with not having heat in your system. Why? Because now with a bunch of coils in my system doing what I want, I I can match each coil to each other and create a resonance between them. That's why. A lot of this stuff's understandable once you understand what the parts do. Sometimes it becomes completely understandable if you're over there just checking off numbers because it looks like what you need. May not be the reactance that your system wants. You say, well, I was trained to do this. I was trained to do this. I was trained to do this. I understand that. And they trained you right. But it doesn't mean that what you're doing is right. It means you're doing what they said to do. But doesn't mean that that's the way the system's asking you to do it. There's a big difference there. I get that a lot. Well, I was an engineer and I do this. Okay, I'm not an engineer, but here, I just did it the way you told me it wouldn't work, and it works perfectly fine. Why? Because I have an imagination. You have an engineering degree. Sorry. That's the way it works. I properly understood field coupling. So, I think it's funny, man. I've been soldering wires since I was 11 years old, brother. So many different wiring harnesses for so many different jobs. I grew up because my mom did that for a living, you know what I mean? So we all learned a long time ago how to solder stuff, how to put things together, how to check them through different systems, what anomalies show up in each system, and they do. And then you got to go through and you got to change values and stuff in there in order to work with the creator of the board or whatever it is in order to fix it. Well, you're going to learn that a lot real early on in life, and then you're going to be able to fix a lot of this stuff. You don't need a big degree to do that. You just need to understand it properly. Sometimes, man, you just over there and you go, well, that's because you put this over here instead of this over here, and it changes the frequency in the system. And you didn't realize it did. It created a heat bubble, and it just ruined your whole system. Some of the time, people don't understand that you put too much temperature near a system, you're going to change it. That's a problem. I love that one. That's the one that gets everybody. They don't have to understand how outside forces affects it. It's usually a one-way system where it blows out hot air. Yeah. Not when you get them to run cool. So I was also checking on another thing. So just understand this. Gerald keeps telling me that what I build is a spark gap when it comes to the RAV. And I'm laughing. And there is a correlation there, okay? There is. I don't know that he understood what the correlation was, but there is. So if you have a spark gap in your system, set your anode and cathode, but precondition your cathode. Hit it with a little bit of energy first, condition it, then run it. A lot of people just turn them on and see what they do. Failure. Turn it on for a second, condition that cathode. It'll melt a little bit. Leave it alone. Okay, use a thinner wire. What happens after that is you start creating RAVs. Now what happens? Now it starts to play with the frequency of the entire system and level it out. Your spark gap became a RAV inside there and leveled it out. He wasn't wrong about that part about it. He didn't know that it did that, though. He just thought, hey, it sparked. Well, that's not what it did at all. It made a structure coherent plasma, structure. It structures the plasma because you preset the condition in the cathode. Now it runs more efficiently. It'll go from 240 degrees down to room temperature. What does that do for your system? It takes hysteresis and throws it right out. Now we got something. Sorry. It is close to the same, but it's not the same. Why does the frequency and structure matter on the RAV? Because you're literally building out crystal with it. You go, hold on, it's building out crystal. Yeah, it builds out a crystal lattice. Is that what I tell you about a planet? Builds out the crystal first. It's an understanding beyond what they tell you. but you never gave it the chance to get to that level. That's the problem. Now that we know it, again, we see all the growth that comes off of it, like the snowflake, stuff like that. Sean has another name for them out there, but it's essentially it's an effect of how things are structuring. You go into plasma and watch it structure in glass, and you start to see, oh man, there's fractals everywhere. Yeah. Nature has to deconstruct everything down to its smallest component and rebuild it through the voltage going on in order for everything to build. You say, well, that's not the way humans are. Are you sure? We have synapses and everything in our body right now. Right now, all your brain, everything works on a voltage system. We have a very thick skin, and things don't get through it. There's nothing saying that you can't once you understand it. Bit of difference. You know, I shouldn't say it. I get in trouble. Anyway, there's a way to fix all of it. You just have to realize what you're doing. One cool thing I will tell you, okay? If you create Tesla coils and stack them, okay, think about this. Usually use an 11, about 11 and a quarter inch Tesla coil, okay, on the number twos. Stack the number twos, okay, solder them together, okay, bottom to top, just like that, and keep stacking them. Your frequency goes like this. But then you don't have to keep stacking them if, and it's if, you can put them next to each other without being too far away from each other, where they can couple capacitance. Once you could do that, you'll start lowering the frequency a lot more. Why does that matter? One Tesla coil is about 200 to 260 on the kilohertz. Two Tesla coils together is about 150 on the kilohertz scale. Three Tesla coils together is getting down almost to your hertz range. Four Tesla coils, again, you get where I'm going here, right? I say, well, Nathan, I need only 880 hertz. Or I need 440 or 432. Okay? Start stacking them. Start getting down to the level you need to. Now, geometrical pattern and stacking and coupled capacitance matters. That's why they tell you not to get that, not to make a field around it and have a center monopole in the center of it, because then you might be in trouble. Why? Because you're dealing with the frequency that's so low that it starts to have troubles in the environment, because those are the environmental frequencies that are real low. Tesla found that out when he started shaking things. You think a low frequency is a bad thing. That's the one that over time is so much better. It's opposite of the way you think about it, because we're all power, more power, more power. It's not the way it works. Less power, more frequency. Total opposite way of understanding it, because you're coupling the capacitance. That means that if I have three Tesla number twos over here and I have a driving coil, what's my trigger on my driving coil? You say, well, it's 3 volts, right? Well, what does that mean? As soon as I put it into here to each one of them, they now couple in capacitance of 3. 1, 2, 3. 3 capacitors working together, okay, for the energy. They hold that energy. Just understand that. They hold it as a capacitor. What does that mean for your input of energy over here on your driving coil? It goes down to your trigger rate. Now, you're running this thing at 3 volts of your trigger rate while these all run, but the energy coming out of these is 4 to 5 times the energy that's in this driving coil. It's coupled capacitance holding in energy. So when I start telling you about an energy field, that's what I'm talking about. I'm coupling the capacitance with an energy, and then as I compress them, I'm squeezing the capacitance of energy. Now the flow of the energy going around them is now laminar flow. I went from chunky flow to laminar flow. That's how it's done. That's how energy works. So when we get to a Otis T car, you start to look at all the different coils they had on the outside, right? Oh, those are a couple of capacitance to each other. Boom, 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 right? Center capacitance. Now I can lower the amount of energy going into the craft, but I can run it any way I want. Complete control of systems. We're changing the way it's done here, guys. That's why we're doing the list the way we're doing it. Everybody starts out with something that seems like over unity. We go to Bedini. If it does 1 battery to 8 batteries in charging, we've got it. Okay, why? Because how I multiply that out, going into every system I can create going on after that, I could run one system in order to run 40 systems off of it. Well, who's paying for the other 40? The batteries that he's charging. You go, oh, well, that makes me, it's pretty good. Yeah, it's pretty good. Like it. Yeah, well, it's the understanding of how to work the energy right. You see, they always compare 1 to 1 when you talk to anything or you talk to AI, and you got to watch for that because they'll keep doing it. Even though you tell them not to, they keep doing it. And you got to specifically say, stop that shit. Okay? I had to do it several times. No, you're injecting stuff in this conversation that I didn't, adding values that don't belong. You're adding numbers that don't belong here. I'm asking a very straightforward question. Anyway, don't drink the Kool-Aids. I like Kool-Aid. I like grape. I'm just going to tell you this. Like, there's a lot of systems out there that are higher amount of energy. A lot of them is doing the accounting right. Okay? Just understand this. There's a fundamental way to understand this. You have to account for the energy outside. If you have a closed and open system, which 99% of systems are, and they say, no, mine's closed. Well, do you have hysteresis in your system? Yes. Well, that's your open portion of your system. It's one way, and you failed. Okay? Let's ask the question again. Okay? Closed system and an open system, an environmentally capacitant system. Now you have to do your accounting. I put 12 volts in. My system's running. It's pulling in extra energy. Where's the extra energy coming from? The environment. How many joules of energy are in the earth? I now have to write that in my equation. Is it technically over unity? No. Is it more energy than the system than what you put in? Yes. It's the way that you understand it is different. Okay? Is that technically over unity? No, because of the joules in the environment. But is it over unity to that one system? Yes. This is a really frustrating conversation to have, okay? I can tell you that because getting something to understand it, this ChatGPT or anything else is kind of hard because they like to try to throw extra stuff in. They start to tell you about windmills and solar panels and all the fluff. Well, that shit don't work. One, you don't let us put enough efficiency in solar panels. They should be 80% efficient. They're less than 20. It's absolutely ridiculous. You can rewire the battery on your solar panel and get double the efficiency out of it. That's a neat trick. Why is it doing it? Because you're being held back. That's why. They don't like to tell you the answers because that's the truth. Now, there's no lie in saying that. That's the accounting. But I can pull as much atmospheric energy as I want. Sorry, I can. And there's not a damn thing you can do about it. I just know how to couple to feel better. Once you know how to couple to feel better, now you're able to pull it in better. That's why when I go over and I take my Tesla coil, put it to a bifilar coil, if I put it to my Rodin coil, and I put the wire down the center, and I pull it out, and I'll show it right in front of the camera, well, that light bulb's still lit. Over there sitting on top of a coil lit, and I'm waving the wire in front of your face. And you're going, well, how did I hold the energy in there? Because it pulled it from the environment. I made a couple of capacitance with the environment as soon as I did it. Now it's deflating the bubble around it until that bubble gets back to the other source. You go, well, how come everybody doesn't do this? Well, because nobody sees it the way I do, I guess. I literally went over to my Tesla coil, put the wire down the center, hooked it over to my Rodin coil, put the lot on top of my Rodin coil, went over there, pulled the wire out of my Tesla coil. I got 12 volts, waved it in front of your face. Yet it still had energy in the Rodin coil for a little while afterward. And you go, what? Coupled capacitance with the air. They say Tesla coils capacitance to ground. Well, not when you change the structure of it. You're changing the geometry of the energy that you're in. Therefore, now it's capacitance to the coil. It's not a grounding effect anymore. It's capacitance to the coil. Now it'll stay around there until that field comes down to nothing. That's why I say the room temperature will come back into it until the room temperature hits it just like that and dissolves it. It means the capacitance field is going down, 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 down until it drops to the coil. Then the energy's gone. They work perfectly together. Why? Because the outside of a Tesla coil is different than the inside of a Tesla coil. The inside of a Tesla coil is like a pulsed DC. The outside of a Tesla coil is like a pulsed AC. There's a diode effect that's going on in there you're not realizing. Because of that, you're not understanding what it's doing to the environment and the different kinds of energy it's creating. That's the trick. That's it right there. You just have to realize, hey, the guy isn't creating anything new. He's simply using the right way to understand it. How does that lead to field effects? Because now I know I can couple with the environment in order to create the field around it, which means that there should be, for every anti-gravity craft, if you turn it off, it should stay in the air for 30 seconds to a minute longer than when you turn the energy off. That happens in the Gravity Flyer. Those videos showed you everything. It's a testament to how smart he was. Yeah, there's a half-life in it. Well, it makes sense. You go, well, how do you couple with the environment? Radiation. Yeah. Once you put it all together, it starts to make sense, right? Radioactive half-life, capacitance inside of it. How does the demon core work? Same exact way. Nothing creates it until you have compression of it. Once it compresses, the field goes out further. All those things are absolutely true. I'll tell you another way to see it. We saw it in the RAV. As soon as you have two of them going, is what they do. Okay? You can add more energy to the field and they just, boom, they burst further. Boom, bigger. Boom, boom. It's a pulse rate. It's a, how do I want to say that? It's like two Tesla coils sitting next to each other. And if you have them slightly off from each other on the frequency, then you're going to beat in between it and the light. You create divisions. Boom, 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 in the light. That's why I showed you guys the video. Divisions. It works the same way. You don't have to have them coupled to the same frequency. You have them close. They say that energy cancels out. I don't think that can be right. I'll say it the way I think that they said it, but I don't think it's right. Okay? In the way that they said it. That if you have frequency out there and you create a frequency in the opposite way, it cancels out. Energy does not collapse like that. I'm sorry, it doesn't. If that's the way they meant it, they were wrong. Okay? If they meant it another way, then I'm sorry. Energy amplifies on both sides, giving the feeling that it seems like it's canceled out. It's not. What happens is energy gets in, like, if I create a lot of polka dots over here and a lot of polka dots over here, they're going to saturate the polka dots in the center. Okay? That's the way it's going to work. It didn't cancel out. The energy's all there. It's all there. It just doesn't have a magnetic portion to it that's making it jump. It doesn't have an amperage making the field go haywire, but all the energy's there. Okay, it doesn't cancel out to zero. This isn't a math equation. This is an energy equation. And in energy, it never cancels out because you can't destroy it. If you're telling me that the energy cancels out, then you're telling me you can destroy energy. You can't. If you said that there was a huge burst of heat, you didn't cancel it. You expanded the heat, which means you converted it. But you didn't destroy it. You didn't cancel it. You cannot cancel it. You may not notice it's there, but it's there. I think they got the saying wrong, or I misunderstood them wrong, because if that's what they're trying to say, they got a chance in hell when we go to show it. Okay? Transformed, yes. I agree with transformed. I agree with blasting it out. I believe it put it into an inert field, which means that they saturated each other into an inert field, but that's still not canceling each other out. Sorry. The energy's all still there. As soon as you change it, just by a little bit, a burst of energy comes out of it. Where the hell did all the energy come from? Because they didn't cancel each other out. Anyway, guys, I'm excited, man. I'm giddy to work that little table saw I got. I want to create this Bedini motor, man. I want it to look perfect. Okay, I want to get in there and sand on it. I want to get into it to make it look really nice. I want it to be like a jewel of my collection, of things that I build. And I'm going to do everything I can to give you guys all the information on it. Okay, good, bad, and different. Argue with it, don't argue with it. It'll be there for you. A nice resource for everybody. So I hope everybody understands that, man. We're going to go into a different level of all of this stuff. So I'm hoping that everybody takes the journey with me, man. But anyway, with that said, man, I hope everybody has a great night. I thank everybody for coming out and listening to me today. Guys, if you have a membership, you're going to be seeing the videos in the next couple of days of this thing being built. Enjoy it. It's going to be awesome. You'll see step by step, and I'll try to do more creative parts of the videos, but you'll see a little behind the scenes action of what I'm actually doing. And I think a lot of you appreciate that. So member up, guys, because it's going to be definitely worth it here in the next 12 months. You're going to get a lot of value out of it. With that said, guys, have yourselves a great night.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. wheels of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds